Defense, culminating as the Acting Director of Cost Assessment and Program Evaluation, also known as CAPE. Dr. Brumer holds a PhD in chemical physics and a Master's of Science in Chemistry from Harvard University. After conducting postdoctoral research at Harvard on the physics of complex biological systems and applications to cancer, he joined the Department of Homeland Security's Science and Technology Directorate as a fellow with the American Association for the Advancement of Science, where he was a pioneering member of numerous key programs. Dr. Brumer has received the highest civilian medal awarded by the Department of Defense, the Defense Distinguished Civilian Service Medal, as well as the Presidential Meritorious Executive Rank Award, the Secretary of Defense Medal for Meritorious Civilian Service twice, the Secretary of Defense Award for Excellence, and many other awards. When not working, Dr. Brumer enjoys spending time with his fantastic wife, Kim, and their two excellent children, Eliana and Nathaniel. Please welcome Dr. Brumer here. Wow, what an amazing biography. We're so pleased to have you here. I'm going to turn over the mic to you.
After a good intro, I always feel like I should just not say anything because it's not going to get any better from here. So all right. First of all, thank you everybody for your time and attention. I know everybody's really busy and I really enjoy things like this, and I do appreciate the time. The question I was asked was, okay, tell me a little bit about how you got in this field and your background, and then what are the opportunities in AI in healthcare, and what are the challenges, and how are you going to overcome them? And then to end with career advice. I'm going to end with career advice. So first, just my background. We heard, I started as a physicist. I switched over to the government, did a whole bunch of things there, left the government about 3 years ago because I had become close to a guy named Graham Verstandig, who is one of these visionary geniuses, drops out of college, starts his first company, totally revolutionizes digital healthcare, and then proceeds to do a whole bunch of other things. Had most recently started one of the very few unicorn, billion-dollar startups in the defense world. And we were thinking about, I on the defense side, he on the healthcare side, there is this enormous gap between the bureaucracies that control those industries and the innovation centers of our country. Defense and healthcare are two industries where you have these outsized bureaucracies that are really well-meaning, but control enormous resources and are deeply subject to the innovator's dilemma. And they struggle to be revolutionary. They're really good at being evolutionary, but they struggle to be revolutionary. And then on the other side, America has this unbelievable revolutionary technology industry. And if you could just connect those two things, you could do something amazing. And that's what Red Cell was really intended to do. So when Grant asked me to join, I was really excited. And Red Cell's been building companies ever since. And the specific company I think of interest is Zephyr. Zephyr is AI for healthcare, drug discovery, precision medicine, started in oncology, has expanded to a variety of other diseases, and is doing absolutely amazing things. And I'll talk about that in a little bit. The opportunity in healthcare is literally infinite. And I don't say that facetiously, and I'm generally a skeptic of future technology predictions. But I am a believer that there is effectively no limit on the positive impact that AI can have on healthcare. And I believe that because of how I think about the limitations in current healthcare. To me, you can take healthcare today it's unbelievable. If you stop and spend some time thinking about where we are today versus where we were a couple of hundred years ago, things that were a death sentence 200 years ago are now, just stop by CVS and pick up a pill and you're fine. And you go into a doctor's office with a broken leg and they look inside your leg and we act like that's normal. And then if they need to, they cut you open, right? And they fix some stuff. And then, if you get a post-surgical infection, they just give you this magic pill so you don't die, which is amazing, right? And the things that the healthcare system can do are astonishing, but they're limited in a couple of fundamental ways. And the reason they're limited is because of the way that we moved so fast forward so quickly. There are tools that the healthcare industry uses to advance. And the best example is the clinical trial. The clinical trial is an unbelievably powerful tool for figuring out what the effect of a particular intervention is on a population. And the way you do that, you gather a bunch of people, you look for particular characteristics, you do an intervention, you track what happens to them, and then you come out and you say, hey, turns out this antibiotic cures this infection, or it doesn't, right? And that's unbelievably powerful because it took us from the age of anecdotes, where some things we learned were right. Hey, if you eat the willow tree, your pain goes away. And some things we learned were wrong. If you put leeches on your body, it's not great. And it took us into this era of science-driven healthcare, which has been amazing. But there are key limitations. And the first is it creates this bright red line between what we know and what we don't know. So we know, for example, what to do with a bacterial infection. We struggle much more with what to do with a viral infection. If you go into a doctor with high cholesterol or type 2 diabetes, there's an unbelievable array of things they can do. But if you go in with a degenerative neurological disorder that we haven't yet categorized, then you're in real trouble. And I mean, the best cancer is the best example, because if you go in with this cancer, they know exactly what to do and you're fine. You go in with this cancer and they know they can't do anything and they know you're not fine. And in the middle are a set of things where we can give you treatments and tell you, we think there's a 33% chance that you're going to be okay, but we can't do better than that. AI presents, and I'll talk about why, the opportunity to move that line of what we know and what we do know way, way across the don't know line. The second thing that healthcare really struggles with is precision. So if every single person in this room goes into the doctor and presents with strep throat, we're going to get very similar prescriptions. And that's good, actually, because for the most part, it's going to work. And we're all going to react a little bit differently. It'll take a little longer for one person to get better, and one of us will have a side effect, but we're all going to be treated very similarly. That works for certain things. But when you get to take my cancer example, right? There's this set of people who we know, we can look at them and say, the best treatment we can give you is 50% likely to give you a 5-year lifespan. But we can't tell you whether you're in this 50% or that 50%. And we know that it is theoretically possible to differentiate those two people. We just don't know how to do it. And that is the kind of thing for which AI is perfectly suited to go in and do precision medicine. Those are the two things that Zephyr is really working on. And I'm going to talk a little bit about how you get after that when I talk about some of the challenges. The third shortcoming in healthcare shortcoming is not exactly the right word. The third opportunity is healthcare is very administratively burdened. And that's actually not a bad thing. There's a lot of paperwork and administration and effort and overhead that goes into healthcare. That's necessary because in healthcare, you have imperatives. You have to protect people's privacy. If you don't maintain quality records, you're going to miss important things and you're going to make diagnoses that are wrong. You have to have a system that allows people who cannot afford advanced healthcare to get access to advanced healthcare. These things require administration. There were opportunities to reduce that administrative burden 6 months ago when I kind of agreed to do this. But then with the advent of large language models, and which, most people think of as ChatGPT and some of the others out there, there is an opportunity to drive that burden down, way, way down. And I'll talk about that a little too. The reason I say infinite, the reason I say there's no limit on how much you can improve healthcare with AI is because I believe, and I cannot prove this, but I believe it, that the information required to make the decisions I talked about, to know which patient is going to respond to which medication, to know how to treat the person with the neurological degenerative disorder that we don't understand, exists in data that humans currently have. And what AI can do that no algorithms have been able to do before is pull insights out of data in a way that we've never seen before. So if we can gather all that data and we can actually make it accessible and we can apply advanced algorithms to it, then we actually can extract the data the insights to make those choices. And I know that because that's what I'll tell you Zephyr is doing. Zephyr has made predictions about which cancer patients are going to respond and not respond that no clinician on the planet would be able to make. And we've proven it right with real clinical data. Like, hey, the AI says this person will respond and that person won't, and that's what happens. It's amazing. And it's not, by the way, something that I thought humanity was going to be able to do for another 100 years, but we're doing it today. And it's unbelievable. The challenges are also real. I don't want to belittle this. So there's a lot of challenges, but there are two primary technical challenges, and they make each other worse. The first is the data in many ways is terrible. So we're coming a long way, but data is all over the place. It's, people's laptops. We've just been gathering it for the last few years. Sometimes it's really clean and easy to use. Sometimes it's really dirty. Most importantly, it's sparse. We have a lot of data, but the problem is incredibly complicated. And the more complicated the problem, the more data you need to solve it. And so we may have thousands of lab experiments, but there are, like, if you look at a human being, there are literally billions of things that differentiate that human being from the human being standing next to them. And so thousands of data, sets, which seems like a lot a priori, is very little when you compare it to the number of degrees of freedom you have to deal with. The other problem is the data itself has fundamental problems. So when you're dealing, I used to be a physicist, and in physics, if you do the same calculation twice and you're off in the 8th decimal place, you've done something wrong. And you got to go back and fix it, right? In biology, if you do the same experiment today and tomorrow and you get an answer that's off by like 30%, maybe you did it wrong, or maybe it's fine. Maybe the cells are just not feeling good that day, right? Or, and we know, like, you'll respond to a medication well one day and not well the other day. And that makes data very complicated. Doctors, when they write down the electronic health records, they're not just objectively writing down what they're seeing. They're messaging the insurance company. They're messaging the patient. They have biases. They have, they're having a bad day, so they write it one way. They're having a good day, they write it a different way. And things like that make it very, very hard, because the AIs don't know any of that. They just look at the data and see what's what, and they come back with, this is my best guess at what the data would have said. And that makes it very hard. And those two things together, having sparse and challenging data sets coupled with data that has inherent problems associated with it, those two things make each other worse. But I think it can be overcome. And the way you overcome it, I think, is by hitting two sides. It's what I usually call the oil and the oil rig. So there's this data is oil philosophy out there that, the way to do AI is gather an infinite amount of data together, and then you build the, algorithms on top of that. That actually is a pretty good analogy for a lot of things. Like, if you want to build a self-driving car, like, the first thing you need is a lot of miles on record, so that the AI has a lot of miles to learn. And you're way better off with 1 million miles than you are with 100,000 miles. But because we're at the cutting edge of what AI can really pull out of data, and because of the problems I'm describing, you also need what I usually refer to as like the best oil rig on the planet. You need next generation algorithms that can squeeze tiny bits of signal out of this enormous amount of noise. Those two things together are I think the key, and that I think is something Zephyr did really well. Our third co-founder after Grant and I, a guy named Jeff Sherman, who's an incredible technologist, built algorithms that can do things nobody else has been able to do. And once we had that, we could start going around to the people who have the data and saying, look what we can do. And then they want to share the data, and then you start gathering all the data, and then you have the oil and the oil rig, and all of a sudden you're doing this amazing stuff. And I think that's plausible across the spectrum. I think if we do this right, I think we're looking at saving at least millions, maybe hundreds of millions of lives in a decade, not in a century. So to me, I think the opportunity is absolutely endless. The other piece, the administrative burden piece, I will tell you, I know it's going to get vastly better. I know that AI is going to make it vastly better. I know large learning models are going to make a huge difference. But I don't know how. I've been thinking about it, but I cannot tell you today, this is the path that's going to work and this is the path that's not going to work. I can only tell you that there's something there that I think is going to be game changing. And the last thing that I think AI can do, which the healthcare system isn't focused on, I wouldn't say isn't great at, is not a fair comment, isn't focused on, is prevention and well-being and enhancement. So what I mean by that is the healthcare system is heavily focused on making the sick well. It is vastly better to keep people from getting sick in the first place, but we don't really know how. We know certain things: don't smoke, don't eat processed meat, that kind of thing. But we're really bad at looking at like 10 people and saying that person is going to get lung cancer, that person is going to get diabetes, that person's, we just can't do that. We can give you guesses and estimates, and we can tell you, we know, this person is more likely to have lung cancer because they smoked for 60 years, but we really can't tell the difference. I actually believe that when we start to gather all of these data sets together and really squeeze the insight out of them, we're going to be able to start calling people in when they're 30 and saying, hey, listen, you are going to get melanoma when you're 60. So you have to use sunscreen. You have, and I think we'll be able to do that across the board. And I don't know if that's 10 years away, that may be 20 or 30 years away, but I don't think we're that far. And we're already, at Zephyr, we're doing things like ER visit predictions. And like just that, the difference between you're going to the ER tomorrow, so why don't you go to the hospital today, and versus waiting until after you've had your crisis and sending you to the ER, is an enormous difference in outcomes, in quality of life and well-being, right? I mean, the difference between being not sick and being well is significant. And I think there is a lot to be learned in how do I take somebody who's okay, they're doing fine, they're not sick, and making them feel well. And what I mean by, I use the word enhancement, which isn't exactly the right word. It's positivity. I don't know the exact right word, but it is making people feel their best, operate at their healthiest. We're not, the healthcare system isn't focused on that. And I think that's somewhere, and I think the data exists today. That piece, the illness prevention is I think harder than the help people feel well. We know that certain people respond really well to this type of diet, and people respond to that type of diet. We know that certain people, struggle with this type of exercise or that type. We're not far away from being able to do precise prescriptions for, hey, here's something that you can do that's actually relatively easy for you, that will make you feel better, that will make you healthier. So I'm really excited about that. It was proposed that I end with 2 pieces of career advice. So I have like 40 pieces of career advice. So I thought about which 2 I want to say, and I'll give you the 2 that I think are 2 that I haven't heard from other places before. And the first is to study influence. It's not something I've ever heard anybody else say. We live in this fascinating nation that creates the best of everything. We have this educational system creates amazing scientists and amazing plumbers and amazing electricians, and everybody's great at everything. But we never train anybody in how to use those insights to influence others. So I studied, I don't know, 40,000 hours of how to be a scientist and how to be analytical and how to be thoughtful. And then I got thrown into this job where my job description is go analyze stuff and influence senior leaders to do the things the analysis suggests. And the first half, I was like, oh, I know how to do this. And the second half, I was like, no one ever taught me this. And what happens is you end up with this nation where where you get on Facebook or like the comments section on the internet, and everybody has a position but absolutely no one is influencing anybody else. How many times have you been on the internet and seen somebody say, I thought this, but then I read the comments section and I changed my mind completely, right? Because we're not trained to be influential. And there is an art and a science of influence, and you can study it and you can learn to be influential, and it's not hard. There's a book called How to Win Friends and Influence People, and it's fantastic. And there's 100 other books out there like it, and there's YouTube videos and classes, and a very small investment of time can be life-changing. The second piece of advice I would give is the piece of advice my father gave me, best piece of career advice I ever got. I was at work and I was just like melting down because there was a bunch of just like stuff going on. And I called my father and I was like, and this person's doing this and this person's doing that. And he said to me, he said, Yisroel, when everything is going badly at work, you go back to your desk and do great work. And that's it. Because great work always wins, right? And that always really stuck with me. And I stuck to that. I can't tell you how many times I was in the office and like everybody's yelling at each other and angry. And I was just like, I don't want any part of this. I'm going back to my desk. I'm going to do some great work, right? And it's true. Great work always wins. I have found that to be incredibly valuable. So anyway, I thank you for your time. I welcome questions. I really appreciate this. Sure.
For our virtual guests.
Yes, Mac Audina. I'm with 11 kilometers per second, which is a business consulting group. The question is, do you think there is a difference between sales and influence? And if so, what do you think those differences are?
Thank you. It's a very thoughtful question, actually. So I think to me, the highest level of sales looks nothing like most people think of sales. I have sold many products and I'm not a salesman. And the way I do it is by creating things that I think are fantastic. And then I go in and I say to people, I built this thing and I think it's fantastic, right? And if, Zephyr is a great example. Zephyr, when we pitch Zephyr to people, we just do demos. I don't sit there and do long, PowerPoint pitches. We just say, hey, let's just show you the product. And either you think it's fantastic or you don't. And early on in Zephyr, we got very mixed reactions. People would kind of look at it and say like, oh, it's interesting and there's potential here, but I've seen other things. And then there was this, and we would use that to go back and make the algorithms better and better and better until one day, senior executives at huge companies would look at it and say, oh my God, I've never seen anything like this. This is amazing, and then they'd be asking us to work with us. And that to me is the optimal sales approach. Our kind of head of growth at Red Cell, I've never seen him sell anything. What he does is he takes ideas and he goes off and he figures out how to modify them, package them so that it is obvious to his target that they need this thing, right? And he'll sometimes disappear for like a month, right? And then come back and be like, and here's how you structure this, right? So all of a sudden or he'll come back and he'll say, we could probably get somebody to buy this, but they don't really need it. So let's go do something else that they really need. So to me, that's how I see sales. I see sales as primarily the intellectual effort to create something that people, once they understand what you've done, really want. And it is a higher level than trying to influence people to buy what you want. I see influence as the art of getting others to understand your side, which isn't the same as agreeing with you. And I think that's actually one of the key points of being influential is if you and I don't agree on something and we have a debate and I realize that you understand comprehensively my side, but you still don't agree with me, I'm super happy. That conversation has been very successful from my perspective. It is your right and your prerogative to disagree with me. I'm unhappy if you don't understand why I'm saying what I'm saying, if you can. And conversely, I need to understand your perspective. And if I don't, that conversation is unsuccessful. If you look at the Facebook arguments, right? The last thing that happens is anybody trying to actually understand the other side, right? Everybody is trying to force sort of their side on. So to me, influence is about kind of opening yourself up to what other people think, and then finding ways to get other people to be open to you. And I think it is a very different art from sales.
Thank you very much for this short but very effective talk. I have a few questions. One of them is, when you talk about issues related to data, is one of the issues related to data being unstructured and posing a lot of challenges?
Absolutely. And in healthcare, unstructured data is a huge problem. And there are massive efforts to clean data, to create structure. Some of them are just impressive human altruistic efforts. Like, the Broad Institute has put together this unbelievable database of the Broad Institute at MIT. Just as an example, like this unbelievable, beautifully curated database of CRISPR experiments and RNA experiments, and they're just doing it for the good of humanity. So in some cases, you can get really nice, really structured data, but for the most part, yeah, if you're going in to do this kind of work, you have to expect to do a good bit of work on structuring things, on cleaning things, and then on the back end, you have to do a fair bit of work on extracting bias from the insights gleaned and so forth. And so yes, the answer to your question is yes.
Do you have a follow-up?
I will ask
Afterwards? Okay. Yeah. Okay, we have a question in the chat. In your opinion, what quality stands out in people looking to pivot into the AI healthcare sector?
That's a great question. So if you're trying to enter a field that is at the cutting edge, I think the two things you need are intellectual curiosity and drive. And notice I didn't say you need a physics degree, and I didn't say you need to be the smartest person on the planet, and I didn't say you need to be intellectually curious and you need to be driven, because getting yourself out into the edges of technology is very, very hard and very, very frustrating. And it is not a job for people who are not driven to succeed. The number, I will tell you, when Zephyr started, the number of times that we just kind of looked at the whole thing and we're like, wow, I mean, this ain't going anywhere. I mean, everything we've done is just, we have encountered a barrier we cannot overcome. And you need that drive so that you are incapable of not pulling 3 straight all-nighters to push through and find a way and get it done. And, and then on the other end, you say, oh, now I know how to do it. If you don't have that, then you really are going to struggle in kind of the jungle of next generation technology. And you have to be intellectually curious. You have to kind of constantly chase down, why everything looks right, except for this one tiny little detail over here that doesn't look right. And if you're not intellectually curious and it doesn't bother you, then you'll do good work, but you're never going to do great work. And it's the people who kind of constantly chasing that. Those are the people who say, well, the reason this is wrong is because this entire fundamental assumption is wrong. And if we do it an entirely different way, we have a massive breakthrough. all the rest, I mean, I have like a whole like wall of degrees, and you know, my my boss at Red Cell dropped out of college, you know, and there are various ways to gain knowledge, and there are various ways to gain insight, and there are various ways to learn. But if you are deeply curious and deeply driven, you'll find those ways.
With AI and large language models, information is available to what we'll call the citizen scientists. In other words, I used to work at NIH. I'd go to the library, I'd pull articles, then we'd put them together for publication. Now I can do that in an afternoon, what used to take me weeks to do. Now I'm going to put that together with something that's emerging in medicine, and that's long COVID. We know that just under 20 million people have cancer, and of course that's a large concern. But 20 to 30 million people and growing have long COVID. Do you see a way for citizen scientists to leverage AI to solve this problem that's emerging?
That's like the best question I've gotten in a decade. So no, these are all good questions. It's a really good question. So I'm going to first punt the question and then attempt to answer. I don't know. I said this before, but I really mean it. I don't know what the effects of large language models is going to be. I believe that we are seeing a technology that has the potential to be disruptive on an enormous level, but I cannot tell you whether this is the telephone or the internet or farming or something less than or more than. I don't know, because it's so early, and because people haven't figured it out. I can't tell you whether the effect is going to be that you're going to empower the broader population to advance science the way you're describing, or conversely, you're going to support what I'll call flawed science, where people who don't really understand a topic now are even more empowered to do a little bit of work and feel like they understand something, and then the waters get muddied. What I can say is that I do think that we are at an age where an individual who is well-meaning and well-versed in the fundamentals of how science works, not necessarily science. You don't have to be a physicist, but you have to understand the concept of a hypothesis and the test and what that means, and what rigorous research means, and the difference between I am making an argument that supports my hypothesis versus I am attempting to disprove my hypothesis through rigorous effort. I think that every one of these advancements will increasingly empower such people, and I do think that there is a long history of individuals who were not necessarily, you don't have to be a professor at Yale to do great research, and I do think that these tools are going to be empowering.
Well, we are at a community college. So what are some ways that students from this college could go out and find opportunities, not necessarily on cutting edge technology related projects, but other ones in AI from a community college?
So I'm going to go back to do great work as my answer to that question. I do think that having, I had advantages. There's no question, but I have watched folks with really prestigious degrees do okay, and people who have no degrees at all do fantastic. And I think that I've seen the opposite too. I mean, I think that different people benefit from different types of education. I do think that your opportunities initially will correlate with your educational background, but that lasts for a couple of years. And then after that, it's who did the best work. And if you're doing better work than everybody else, you're working harder, you're being more insightful. And by the way, working harder does not mean you're working 18 hours a day. It means that when you're thinking, your brain is in 5th gear when everybody else's brain is in 4th gear. That gets noticed. And I have, over the course of my career, I've pulled a number of people from relatively low level positions, and they are now senior executives because they just did beautiful work from wherever they were. They were contract officers, and they got a an entry level position in contract, and they did amazing work. So I'm going to give them something else and see what they can do, right? And then they did amazing work. So by eventually they're running some gargantuan portfolio because they just do great work. So my answer to that question is you go out and you get the job as close to your target as you possibly can, and then you just focus on crushing it. And then you just continue to focus on crushing it, and amazing things will happen.
We have a question in the chat, and then I'll come back to you. Do you think AI would assist be able to speed up processes such as vaccine productions in the future as more data becomes available and the AI technology has better understanding of illnesses and diseases?
Yeah, 100%. I think that we are actually not far from a point where AI is going to be involved in finding novel targets for whether it's a vaccine or a drug intervention or other therapies. When we're running clinical trials, I think that AI is going to be very soon involved in picking out who is a participant in the clinical trial, which will significantly increase your probability that clinical trials succeed. I think that clinical trials will go faster. I think we are not far from a point where you're going to start to see label expansions with existing therapeutics being used for novel disease states where we don't know how to cure this disease, but it turns out there's already an FDA-approved medication that can do it. And no one would have thought of it, but the AI comes up with it. And we're actually seeing a lot of that at Zephyr. And I don't think we're very far from that. So the answer to your question is yes.
I just wanted to say something to the question he asked. There's a book called So Good They Can't Ignore You by Cal Newport. I recommend that for students. I'm recommending for my son who's going to college next year. I mean, in August. So the question, what is the difference between what we're calling intelligence and, like data processing and analysis? Is the human still doing the actual intelligence? Or like you just mentioned that there was something that no one would have thought of. Did the AI actually think of that, that combination of things? Or yeah, that's the question.
So you can have a 2-hour discussion on this, which I know because I literally had a 2-hour discussion on this last night. And it's very complicated. My favorite definition of AI, okay, is somebody who said that AI is the thing that your computer cannot do, but is just about to be able to do, right? And then as soon as your computer can do it, we don't call it AI anymore, right? So there's a lot of things that your computer is doing on a daily basis that in 1965 we would have called mind-blowing artificial intelligence, but we don't think of it that way. We don't know what intelligence is. We cannot meaningfully explain how humans are different from other animals, how other animals are different from lower level organisms. We don't understand it scientifically or philosophically. We think we do, which is dangerous. But when you stop and think about it, we really don't know. So artificial intelligence today can be thought of as a massive mathematical correlation finder, right? A chat GPT asks itself the question, what is the most likely next word that the massive amount of words I've ingested would be, right? And then there's a bunch of other stuff, but at the core, right, that's what it's doing. And then it spits out the next word and the next word, right? And it produces sentences that sound remarkably like the one you would have said, right? When I say the AI thought of a label expansion idea, it means that the AI looked at these massive amounts of data that's ingested. And then when we ask it the question, what is your best guess about what that data would look like if you ask the question, how do I intervene in this disease state? It said, this is my best guess, right? And as you add in more data, it gets better and better. So when you start with an AI that plays chess, at the beginning, it makes terrible guesses. And then at some point, it makes great guesses. And then at some point, it's crushing every grandmaster in the world. But we can't tell you if that is a simulation of how humans behave or whether it is how humans behave, right? And we can't tell you if you push that to the end state, will you get a general intelligence that you would be unable to distinguish from another human being or not? I'm fascinated by the debates on is AI gonna, take over the planet? But my answer is I don't know, because I don't know whether there's a fundamental limit on what artificial intelligence can do because I don't understand the space of intelligence. So your question is probably one of the most important philosophical questions that humanity is facing today, and we just don't know.
I've got a couple of segue comments and then a question. So the comment is, how can somebody at Montgomery College get into artificial intelligence? Well, one of the things I do is I'm an entrepreneur. Number one, go to startup school, startupschool.com, I think it is, by Y Combinator. It's free to join. Y Combinator companies, they're funding about 400 per batch. That's 800 a year. And they've got job postings of these startup companies that are looking for people to work for them. That's number one. You might have to have money to move to California, might be able to work remotely. If you want to find funding to do this, and especially if you're in a disadvantaged or culturally diverse group, go to the National Science Foundation or NIH. The National Science Foundation has $6,000 summer internships for SBIR companies, small business innovation research companies. Just yesterday, I got a similar email from the National Institutes of Aging, and they are using AI in the SBIRs that are going into NIA. And they're offering, get this, $250,000 as add-on funding to companies that already hold SBIR awards to add people on. They can be high school students all the way through postdocs. Great way. You find the funding, you take it to the company hires you. Pretty simple. Anyway, so my next question is quantum. Quantum, we're a big quantum center here in Maryland. You're a physicist. You're also in AI. I know they're using quantum computing to do some analytics of large language computations. Can you elaborate more, please?
I can talk a lot about quantum. I'm actually a second generation quantum mechanic. So I don't know how many people can say that. But I'm not familiar actually with quantum computing on AI, so I honestly can't comment. I can say that I'm very excited about quantum computing. I don't know, I don't know whether it's a year away or 10 years away, but I do think something major is coming.
There's somebody in Maryland.
Yeah. Okay. And I'll go talk to him. Yeah. That's cool. Yeah, I'll look them up.
Thank you. This was a great discussion. We're actually right at time. So I'm glad that you were able to share your insights with us, give us great career advice as well. And then, of course, my favorite part always of these guest speaker series are the questions and the dialogue and the insight and information that we're a community together. It's always a learning community as well. So thank you, everyone, in person and online, for your involvement and engagement. Thank you for your time here. We are, as I was talking about learning, please fill out our survey of our event today, both online and those of you that are in here. This is our first year offering these guest speaker series. So we want to make it better, and we want to bring topics to you that you're interested in and speakers that you want to see here in the hub. So please take a moment to fill that out. Again, thank you, Dr. Brumer, for coming, sharing your insights with us. And until next month for our fireside chat, I look forward to seeing all of you there. Thank you.